Welcome to the Omni-Path Back-to-Back host installation webcast. My name is Michael Savasta, and over the next half hour or so, I'm going to take you step by step in how to configure an Omni-Path link using two cards and two servers. No switch. Let's take a look at how we can do this. So this is the agenda we have for today's webcast. We're going to talk about the installation of the card, the interface itself, known as a host fabric interface. We're going to install the cable. We're going to then load the HFI host stack, the host software, on the servers. We're going to configure the element, the fabric manager installation and verification. This is very, very important because without this component, we have no fabric. Setting up the protocol, IP over Omni-Path. So in the InfiniBand days, we called it the IP over IB, which can also be called that as well today. But it's really the Omni-Path fabric IP stack. So we call it, so we don't confuse it, IP over fabric. Okay, and we're going to use the Fast Fabric toolset when configuring. We're also going to set up passwordless SSH for our hosts because at the end of this particular webcast, we're going to perform a stress test, an MPI stress test. We're going to look at the fabric health. We're going to look for errors. We're going to check the FM for errors. We're going to display link status. We're also going to check for our host connectivity to make sure that both these hosts, both these servers, see themselves 100 gigabit per second connections. And then, like I said, we'll end the session with a simple MPI stress test. So the hit list, it's good, very simple and straightforward. We're going to install the HFI card. We're going to run our Unix command lspci. We're going to verify that we're running at, that we can run at 100 gigabits per second. We're going to also make sure that we're at Gen 3. We must be at Gen 3 in order for us to get the optimal output, or throughput, I should say. We're going to connect the cable, and then we're going to install our software. We're using the command /install -a. This will install all of our primary components, drivers needed to bring up the link. We're going to install the Fabric Manager and configure it to start upon system boot. So one of our hosts, or we can even have both our hosts, run FMs on them. We're going to verify our link is up using the OPA info command. And then we're going to run that simple test. It's a long one, right? MPI jobs, they usually are. But we're going to run it and take a look. So the lab components overview. What are we going to need to perform this exercise? First of all, we're going to need two servers with at least Red Hat 7.1 installed. It can also support SLES, but for this particular webcast, our lab machines are running Red Hat. You're going to need two cards. In the InfiniBand days, we called these cards, the ones that we insert into the PCI Express bus, HCAs, we now call them host fabric interfaces with Omni-Path, known as HFIs. We're going to make sure that the cable that we are using for our OPA, it's a QSFP, but that it's been qualified for Omni-Path. And we're going to need the tarball that contains the Intel Fabric Suite IFS software bundle. If you don't have this, you can download this from our download portal, and I'll be showing you that during this webcast. So let's talk a little bit about this HFI card. First of all, Intel, we have two flavors. We have one that's an X8 that we can basically, using an X8 slot, we can get 56 gigabits per second. We have another one, which is an X16, which we can achieve full bandwidth of 100 gigabits per second. Okay, two different cards. The silicons are basically the same, but they've been tweaked and set because of the PCIe bus slots that you see down below here. They're different sizes, right? So we have more lanes with the PCI. Virtual lanes, we could have 0 through 7, 8 VLs, plus one used for management to communicate with the FM that we'll be installing. MTUs, with Omni-Path, we could have anywhere between 2, 4, 8, and 10K MTU sizes. The 8 and 10s were added from the predecessor TrueScale for storage solutions, okay, for larger packet size for storage. In the interfaces, QSFP 28 quad small form factor pluggable passive copper and or optical cables can be used to connect these two cards together. Now, the cards that we'll be using in our lab are X16 cards. At the end of this webcast, we must see 100 gigabit per second link up. So before we install our HFI card, there's a few things you want to make sure. First of all, in the Omni-Path switch installation prerequisites, we have posted in our user manual, okay, installation guide. You want to make sure all your RPMs are installed. We want to make sure that the card that we're putting in is inserted in a PCIe 16 X16 slot if we want to see 100 gigabits per second. Otherwise, we're going to see 56, right? We're going to have 8 lanes instead of 16. So, our servers in the lab are running X16. We want to verify that our server boots the operating system successfully. And whether you're using Pixie, we want to make sure there's no hardware errors. So before we even get into Omni-Path, let's make sure that the server we have itself is running properly. And, reboot the server and make sure that it boots up successfully and there's no panic attacks or anything like that going on. So that's the first recommendation. So once we know that server is rock and rolling solid, now we can install the HFI card. The HFI card is like installing any other PCIe card. We would remove the host from the rack or the box. We'd open the chassis, of course, using a ground strap for static electricity discharge. We don't want to blow anything up while we're inside this guy here. And we're going to install the X16 in a PCIe slot, an X16 slot. We're going to carefully install this HFI card. We're going to close the chassis. We're going to reinstall the server back in the rack. Going to connect all the cables, power, and eventually QSFP from one HFI to the other. And then we're going to power on the host. Now, when we power on the host, if you look on the back, immediately the green LED should be on where the HFI card has been inserted. All right, so we know that card's powering up, which is great. If your machine comes up and you don't see these green LEDs, we're going to have to do some troubleshooting here. So the green LED, make sure that it is illuminated, because the next step when we go to, check our HFI, and how do we do that? Well, if you're not familiar with Linux, this is a very important command for you. I mean, I was originally a Windows person, and because I became a Fabrics guy, well, Linux is mandatory. So if you're not familiar with Linux, you really maybe want to take a course or pick up Linux for Dummies book, because you should really know the operating system if you're going to get into high performance clusters. But the command that we would use to scan that PCI bus with Linux is a command called lspci. And lspci minus VV, that means very verbose, give us all the information of what is seen on my system. It's going to sweep and scan that whole PCI bus, and it's going to display to you all the devices that have been inserted on that motherboard, on that server. Now, the device that we have for the Intel for our HFI card is a device that has a number, as you can see here, of 24 Foxtrot 0. I can see it's in my PCI slot 5 device number, as you see right here. So right off the bat, my operating system sees the card. This is very exciting because if your operating system doesn't see the card, why load the software? You're not going to get anywhere with it. So we need to make sure that our card is being seen by the operating system. Again, X16 slot if we want that 100 gigabits per second. If you put it in an X8, you're going to get the less bandwidth. We're going to be running at 56 instead of 100. I can also use this command called HFI 1 underscore control minus IV verbose minus grep PCIe. And I can see here that I am in a X16 slot. All right, so this is another good way to make sure that we have put that card in the slot to give us optimal performance. With that LSPCI, because it gives us a lot of information, right? As you can see here in front of you, this is all the information for my device 5, which is that HFI card. As I look down in the middle, I'm going to see something called link capability, and the speed is 8 GTS. This is basically saying we're running at Gen 3. All right, now if you see 5, it's Gen 2. We can also see the width is 16, X16. So I feel pretty good right now that my system, first of all, sees my card, but not that it just sees my card. It's going to run at optimal speed. I'm going to have, I'm going to have 100 gigabit per second link at the end of this webcast, right? Some supporting documents that we have. Our TechPubs team has really been, busy to make sure that we have as much of this documented, but we have the HFI installation guide and the HFI platform guide, which could be of use to you, which can also be downloaded from our site. Connecting your cable. All right, so first thing, it's like InfiniBand or like in TrueScale. We want to be careful when handling cables. We don't want to step on them. We want to, don't kink them. It's basically, I like to say, stay with the traditional 4-inch bend radius. So it's documented at 69 millimeter, which is like 2.71 inches for copper. And then for our optical, it's at 105 millimeters, which is roughly 4 inches, a little more than 4 inches. I like to keep it at a 4-inch bend radius if possible. That's what we always did in the past with fiber channel and storage, and as well as InfiniBand. So still pay attention to when we run the cables. Where this example of this webcast is basically a direct connect, you're not going to have to worry about this. But when we get into the big labs and fabrics with huge director-class chassis, we got many, many, many cables. We need proper management, like the trays, overhead trays, and the arms that connect in our racks, and there's a whole bunch of stuff we got to pay attention to. Cables are very important. This is a highly interconnected fabric. So again, 2 systems, 2 HFIs, very simple. Michael's getting ahead of himself. I apologize. I just get very excited with this stuff. And again, we want to make sure that the cable that we're using has no physical errors. So at the end of the day, you're going to have a connection, something like this, right? You're going to have your cable. You're going to connect it from one server to the other server. And now we can move to the next step, which is loading the software. All right, so because we're going to run this component called the Fabric Manager, and if you really don't know anything about the Fabric Manager, we have other webcasts that you may use or download, and you should really get to understand the components even in a greater detail. But right now, this is the very first start for you. Let's bring up a little mini fabric, okay? So that's what we're going to do. But we want to make sure that we have enough system resources to bring up this FM on our servers. So you want your servers to have minimum of 1 gigabyte, which is really nothing today, right? Our servers have much more than that. And, if we're running compute nodes, we say 500 megabytes. In this webcast, we're going to have 2 management nodes back to back. That means full software installs. All right, and I'm not going to get into all the differences between the Fabric Basic and Advanced, but we can load up software for either just a compute node or full management, meaning FM, all the OPA commands, and really that's what you want, right? You want to play around with some Omni-Path, and that's our final objective here and mission that we're on. Swap space, same thing. Try to keep your swap by the given versions of Linux that you have. We usually say the swap space should be twice the size of the physical memory if you're going to run the Fabric Manager, which we will be running on this cluster. So installing the new host procedure, we're going to download the software, the IFS full set. We're going to untie the file, right? And then we're going to run /install -a script. Now, there's two ways of installing our Fast Fabric Intel Fabric Suite. By either running a TUI, which is a text user interface, which allows you to select by number, corresponding numbers, what modules you want to run. Or you can sit there and say, hey, you know what, just load up everything. I don't need to look at the TUI. Just give it all to me. So /install -a will select the components for you and automatically load those components. Then we would reboot the host and we would verify the installation. Now, you can load and start the Fabric Manager two different ways. Okay, once the server boots back up, it now has all the RPMs. It has all the, the drivers have been loaded for the HFI. It's going to come up and it's going to try to start communicating via a dedicated management lane called VL15 with the FM. So what's going to happen is it's going to come up, but it's not necessarily going to be up. Okay, we loaded the software. We got to make sure that FM is up and running. And we could do that by typing OPA config -e to enable the OPA FM. Okay, and we're going to enable this on at least one node. If you enable it on both, that's okay. One will be in standby. But really, we're talking point to point here. So one is really sufficient. So it depends what you want to do. You can play around and bring them both up. It isn't going to hurt anything. And then we want to make sure the FM is started. So we want to type service OPA FM start or system control start OPA FM service. Okay, and this will start your service. Then we could type service OPA FM status. All right, if we say status, then we could see that it's up and running. So now, really, right now, you should have a link that's up. You should have a Fabric that's up. Now, to get this, our software stack, we have the Intel OPA host software basic or IFS, and the IFS is a superset of the basic. Basic is bare minimum, usually used for the compute nodes when you're in an MPI environment, or you're running your Fast Fabric type of environment. You would have your management on one node, and you'd run your basic on others. It's a smaller set of commands. So we have two different packages. These can be downloaded from our http://downloadcenter.intel.com. All right. With this IFS, we're going to have the Fast Fabric toolset, which has a ton of scripts and wonderful commands. And again, that's for another presentation. And we'll have that Fabric Manager, subnet manager. Very, very important that we have this up and running. All right, and then there is also a Fabric Manager GUI that you could download. That's a very nice application for viewing your your Omni-Path Fabric. So here's an example. If we went to the Intel download center.intel.com, or we can go to the download center and type in Omni-Path, and we could also see the drivers and the software that's available for Omni-Path. So from the download center, we could do this. And then we also have a support center line, which gives us support. So if you need to contact our team, our OPA support team, we have that at Fabric Support, intelfabricsupport.com. Okay. So unpacking the tar ball, we're going to tar XVF, Intel OPA-IFS, and whatever the distro version is. So You know, one of the great things about Omni-Path is this software is also being upstreamed to the distros. So there'll be a part of your Red Hat release or your SLES release bundled right in with it. But if you want the latest and greatest copies, you can go to our download center. So this is really cool, all right? This is different than what we've done in the past with InfiniBand. It's going to be right on the DVD for us. Cool. All right, so we're going to use an SSH session. We're going to log into the server. If you're at the terminal, cool. You're going to be able to maybe maybe you want a shared directory between these two servers if you want to set up NFS, so you have a common share location. That's just, that's for MPI. Right now, we just want to bring the link up, so you don't have to have share just to bring up a link. But you do want SSH, and there's going to be a couple things that we're going to go through after we're done installing the software. So we untar it. We get the software. It's going to give us a directory like you see right here. On the top, we have basic, and over to the right, I have an IFS. This is an older version of software, 438. We don't, you're going to be running something a lot newer than that. But you're going to go to the IFS, the Intel OPA-IFS directory location, and then you're going to see this install. This is the command. This is the launcher to launch and load our host stack. So we're going to type basically /install -A, and that's going to just go automatically off and load everything for you. If you want to see the TUI, you can simply just run .install like I did here, and it's going to bring you up this menu interface. And from this, I can install and select what stacks I want to load, what components. And do I want to load, the OPA tools? Do I want to load the OPA at FM, which we know is important. But for right now, we're recommending for this webcast to run /install -A. It'll do and select all this for you and download it so you have a full operational environment. Okay, now that -A is going to give you all your key modules. Now, once it loads, you're going to want to reboot your server. And now when it comes up, we should see our links now. All right. If everything went successful, everything looked good, there are some log files we can take a look at if we have run into errors, but one of our commands, like OPA port info, it'll display the HFI port state and status. The link is up. This is very, very good. If we see polling, the FM hasn't been started. All right, so you want to double check and make sure that your FM is started, and we'll show you that in a second, how to check that. You want to see your port state is active, and we have an address or a lid, a base lid, and SM lid. You better see an SM lid, because if you don't see an SM lid, you didn't get a base lid. Our FM is assigning a local identifier to this HFI port. The link width, we got ourselves a 4x link, which is awesome. Now with Omni-Path, we support both 1, 2, 3, and 4x links. Okay, meaning we could be a 25 gig, 50 gig, 75 gig, or 100 gigabits per second. What we're running right now, as you can see here with the link speed, is 25 gigabits per second times 4. So there's your 100 gigabits. So high five yourself. You just did a great job. You brought yourself a link up. All right. This is very good. But, it goes through a couple different stages, a link, before it's active. So if it's in an iNet state, then that's most likely telling you a cable hasn't been connected, or it's not detecting the cable. Make sure you plugged in the QSFP cable correctly. If it's in a polling state, that means that, both ends can see each other, but no FM has been seen. All right, so under the physical state, if you see that port state active and you see polling, then what we have right there is we have ourselves a lack of FM. Many documents are available for you. All be downloaded from my download center. The Fabric Manager installation on the host. So to enable the FM, like we just saw earlier, we could type OPA config -E OPA FM. Right? That'll enable it. Now, starting it on the host, if we type service OPA FM start, That's going to start your FM, or we can use the system control start OPA FM option. This will start your FM upon boot. All right. And then we could type status. There's another different things we could do for our host-based FM. We could type service OPA FM status, restart, start, and stop. So if we want to restart the FM, we could restart. If we want to stop, we could stop that. The OPA fabric info. Here I could see my master FM. So when you type OPA fabric info, this is going to give you a summary of all your links. In this case, we have HFI ports, switch chips, links. This is a full fabric connected to a switch. But I'm going to show you right here, as you can see in this output, this is what you would see with a back-to-back. See, you're only going to see the two hosts. You're not going to see switch chips and a whole bunch of links. We want to see 4x. We want to see a 25 gigabit lane to make sure that we're at 100 gigabits per second. We can also query the FM and get some SM info by typing the OPA SA query -O SM info. And if you really want to see what we have for OPA commands and you're not a Linux person, simple. At the prompt, type OPA tab. Look at them all. Yeah, there's a ton to start with. Some of them are $1 million commands, like OPA fabric info, for example, or OPA port info. Okay. We can type that OPA report -? And get output and help for this command. The OPA report is probably one of the most powerful commands that you're going to need to know when working with Omni-Path. It's an awesome command. If you folks are familiar with InfiniBand, I put it right up there with the IB diagnet command. So now we've got the link up. Everything's looking pretty good. But is your fabric healthy? All right. Now, in a real fabric where we got a bunch of switches and hundreds and hundreds of links, we want make sure every one of these links are at 25 gigabit. And remember, that's 1x. And that we have 4, and that we can get the 100 gigabit. So there are some procedures that you would run to make sure that your fabric is healthy. Now, for us, the OPA fabric -V will verify that your 2 nodes are up and running. Here you can see it's going out, it's getting the node records and the link records, and it's getting the cable information. And it's going to take this and it's going to give you a brief summary of exactly what it's seeing back-to-back. Now, this output is an actual back-to-back config. All we're seeing is 2 HFIs talking nicely together, connected physically with 4x 25 gigabit lane, giving us that 100 gigabit pipe. This is awesome. All right. So this is this right now, you should feel really, really good that we have that 100 gigabit connection. All right. We can also use the OPA report -Q, -O BR nodes, -O links, -D 0, and it'll show you again all the components within the fabric. Now, in this example, this has a switch, couple switches, 3 FMs, which we call also subnet managers. Could get sometimes confusing because we use the name, the SM name, the subnet manager was given from IB days to TrueScale's the FM, and now we call it FM. So, but in some of our diagnostics, it displays it as a subnet manager, which is good, right? Same thing, FM, SM, same thing for this course here, for this webcast. If you're not sure if your FM is running properly or you want to see your FM in action, you could grep FM0 in your messages file, /var/log/messages, pipe to tail. And what you should see is by default, our FM is sweeping the fabric, and we're not going to get into in depth, but it's checking that port every 300 seconds or 5 minutes. And then it sits back, and then it goes back out, and it checks all the ports. This is how one of the manager's responsibilities and primary responsibilities is that it sweeps the fabric and checks our ports, our links, all kinds of stuff. All right. So again, without a fabric manager or a subnet manager, we have no fabric. Those links in a fabric where we have many links, okay, even with this one, we want to make sure there's no errors between those links. So if you're running you're running a job or whatever, we want to check for slow links. Now, a slow link would be something that is degraded or is potentially, not running at that 4x speed of 100 gigabit, but possibly running at 3x and it's running at 75. Or through 2, it's 50, or 1, it's 25 gigabits. You kind of get my drift here. We can configure that. We call it dynamic lane scaling in Omni-Path. It's one of the features. Right, we want to make sure everything's cool. So OPA report -O errors is an awesome command. It'll check for errors. Here you can see I have no errors, and I've got 36 links here. So it's checking both my links between my switches, which we call ISLs, and switch links, as well as the external cables going out to my business side of the fabric or my chassis or my servers, and it's coming back saying, hey, man, you got no errors. So you should feel pretty good right now. There's a file that contains the thresholds, which is set, which is used by it's been set by the recommended settings from engineering, as you can see here. So link quality indicators and link error recoveries or link down, and we're not going to get into all the different port counters. This is beyond the scope of this webcast, but it's doing all of that for you, and it's checking, and it's coming back saying to you point blank, hey, no errors found. Nice command. And again, this is your OPA report, -O. Errors, I'm checking for errors, which are the error counters, as well as any slow links, any 1x links or 2x links or 3x links, etc. All right. So checking link quality, we can run OPA -O none and clear all. That'll clear all the counters, and then we could check our slow links like we just did. Remember that 4x is what we're looking for. That gives us the 100 gigabit. OPA can also be shown as 25 gigabit per lane. So if we've got 4x, there's your 100. If you've got a 3x, there's 75. And we might have a problem. All right, so now you know how to even check your links, now that we have that up. Configuring IP over fabric and passwordless SSH using fast fabric. You want to select from that TUI. You want to go to the reconfigure OFED IP over IB. See, we're calling it IP over IB in the TUI right now, but that's going to be changed with the GA release. That's going to say IP over fabric. We're going to configure the IP stack for our HFI port. So there are a couple things you want to have done before we start setting this up, and one of it is we want to make sure right here that the etc host file, and that shouldn't have a dot at the end of etc. You got to love spell checker. That's /etc/hosts, that we have defined the name of the two hosts in this file. Now it's very important that we see the -OPA, because in our scripts we're looking for that prefix or suffix, I should say. All right, so if you've named your host, host 1 and host 2, in that etc file, it must have host 1 -OPA and host 2 -OPA. All right, so that's important. So when we run the TUI, it's going to say configure OFA IP over IB version 4 address, yes or no. You're going to go yes, and it's going to start selecting and running the script, and you're going to give it the subnet. You're going to make sure it's going to create the network scripts for you. If we end up having a problem where we can't ping between the two hosts, we need to go into basic Linux network troubleshooting. And again, for you folks that are not familiar with Linux, it can get a little tricky. But at the end of the day, there's this in the sysconfig network scripts it creates a device file, IFCFG, like you see right here. And this device file, if you open it, is going to have the settings for this port. And you want to make sure that the IP address that is given to it, the IP over IB or OPA address, has been given to it appropriately. Because realistically, we've got two cards in this server. We have one that's an Ethernet RJ45 talking to one subnet, which is an Ethernet subnet. And then we have the other one that's the port on the HFI card itself, which is running across this very, very, very fast, low latency, high bandwidth fabric. Two different stacks we're running on two different cards, two different interfaces, right? One's a network interface, the other's an HFI interface. So we want to make sure that this file is set up properly. And you can see here, I typed out one of the ones in the lab here, so you could see exactly what I'm talking about. Give it a little bit of time so you could take a real good look at it. Okay. Passwordless SSH. Yeah, if you Google this, you'll see all different ways of setting this up. But we use this thing called Fast Fabric. It's a nice utility, a nice set of tools. It does require you to have a couple files configured. However, we don't have chassis, so we don't have to worry about the chassis file. But the OPA host file, we do need configured. And with this script, when we run OPA setup SSH, it's going to go out, it's going to look at this script and say, hey, I got two nodes here. I got to make sure that I'm able to open up a SSH session with no password because MPI is going to need this, right? And so this is a good command to know when configuring SSH. Again, this is straight Linux at this point. This is not anything special to Omni-Path. But we have tried to make it easy for you because it can get a little tricky when setting up passwordless SSH, especially if you have hundreds of servers. In this case, we just put 100 OPA host names in this host file. We run this script, and it'll go off and automatically do it for you. So, nice job, guys in engineering, software engineering. All right. And now, if I try to open up an SSH session, watch this. I'm going to put here my node name, hit enter, and look, boom, right in, no password. And I'm going to go to the other node that I have displayed here and open it up the other way. And look at that. Amazingly amazing. That's awesome. So now we have the password list set up. So I can ping across my fabric. And I can open up my SSH session. All right, get up now off your chair and do a little dance. People might look at you, but you've deserved it because you now have set your environment up so that you got it. The final part of this webcast, you've made it. This is very exciting. We can run now a back-to-back MPI stress test to verify the connectivity. All right, and you can run a back-to-back HFI test. Following command line runs for 1 minute, approximately 60 passes. And I ain't going to say all this. I'll let you read it. Hopefully you're writing it down because you're trying this in your lab right now because you're all done dancing in the hallway. All right? And with that being said, questions and answers. Sorry, I can't answer. This is pre-recorded. However, if you have any questions, please feel free to send us an email at fabrictraining@intel.com. Again, my name is Michael Savasta, and I'm hoping that this was a little helpful, bringing up your very first OPA link, and I look forward to meeting you someday. All right? Have yourself a wonderful, wonderful day.